Alright guys, today we're going to go ahead and do part 2 of the first section of chapter 4. So some more integration. We've done the basic stuff of x's. Now we're going to do our favorite thing, which is trig. Okay, so we have the integration of cosine of x dx is equal to sine of x plus c. We have the integration of sine of x dx is not cosine x plus c. The integration of secant squared of x dx is tangent x plus c. The integration of secant x tangent x is secant x plus c. The integration of cosecant squared is not cotangent x plus c. And the integration of cosecant x cotangent x is equal to not cosecant x plus c. Best way to remember it is when you take the integration and you get something with a c, it gets a negative sign. That's all I got for you there. Remember, secant and tangent are buddies, so they create each other. Cotangent and cosecant are buddies, so they work together. Alrighty, so just like we did in the day before, we can take the integration of pieces, and 2 is still considered a coefficient, so I can take him out before I take the integration of my sine. And I can take out my 3 before I take the integration of my cosine. So I have 2 times not cosine of x plus 3 times sine of x. And same idea, we still need our plus c. So I get negative 2 cosine of x plus 3 sine of x plus c. Alright, so I'm going to go ahead and break this up into pieces. So I have the integration of 1 dx minus the integration of cosecant x cotangent x dx. When I take the integration of a constant, we talked yesterday about how I just get whatever the variable is. So since I'm taking with respect to x, my integration here would be x minus negative cosecant x plus c, which turns into x plus cosecant x plus c. Alright, again, I can split everything up because it's based on subtraction and addition signs, so anything with one of those I can split up. I missed my dx there. Integration of secant is tangent. Integration of sine is not cosine, so this turns into a plus. I get rid of c. So I look and I say, hey, wait a minute, I don't have tangent squared in my repertoire of rules. Oops, too far. I have tangent, I have secant tangent, but I don't have tangent squared. So what we need to do is turn this into something that we can actually take the integration of, just like we had to rewrite our integrations with my x's, I have to rewrite my integrations with my trig. So that means, bum, 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 scooch you over, mama, baby, papa. So mama will always be sine squared plus cosine squared is 1. The other two get created by dividing by either sine squared or cosine squared. So if I divide by sine squared over sine squared turns into 1. Cosine over sine is cotangent. 1 over sine is cosecant. If I divide the top by cosine, sine over cosine is tangent. Cosine over cosine is 1. 1 over cosine is secant. Well, by golly, isn't that what I got right up there? So because tangent squared of x plus 1 is equal to secant squared, I can replace that and take the integration of secant squared of x dx. And I know how to take the integration of that guy. The integration of secant squared x dx is just tangent x plus c. Again, I have to simplify before I can take the integration of. So we're going to go ahead and split this guy up. I know I have 2 cosines on the bottom because that's what it means to be squared. However, I only have 1 sine on top, so that means the other thing must be a 1 because 1 times sine is still going to be sine because I'm really not changing it. I'm manipulating it to turn it into something I can actually take the integration of. I've got sine over cosine, which sine over cosine is tangent. And I have 1 over cosine, which is secant. I think I just found one of my integrations of trig. Even though in my rules I have secant tangent, it's with multiplication. So I can flip-flop these guys around if I want. Because just like how you can take the multiplication of 4 times 3, 3 times 4, same thing, they interchange. So my answer is secant x plus c. Alright, see you later, guys.